So let's see the introduction to artificial intelligence, AI, machine learning, deep learning, and generative AI. So the buzzing term right now in any industry, be it healthcare or finance or retail or manufacturing or technical or any non-technical domain, it is AI. So everywhere we have been hearing the term AI, artificial intelligence. So AI is a broad term, so everything together is called artificial intelligence. So what is artificial intelligence? In layman terms, artificial intelligence means trying to mimic humans. So as humans we have intelligence. So how do we mimic humans? For example, let's say you have a kid and you want to teach the kid fruit names. So how do we teach the kid to learn a fruit name? We will teach the kid by showing an apple or orange and teach that the fruit name is apple or orange, and we will also teach the color of apple is red or color of orange is orange color, right? So when we repeatedly train or teach the same thing to the kid, it registers in their brain. And we know the human brain has neurons, right? So when we show the similar image of the fruit, either apple or orange, to the kid multiple times, their brain finds the image pattern, that is neurons in the brain understands the shape or color of apple or orange. So this process is called training. That is, you are showing multiple fruit images to the kid as input and teaching them the output. So that is the label. The label is the output. That is the color of the fruit or shape of the fruit. So input is apple or orange image and the output is either color of the fruit or the shape of the fruit. So once the kid is trained, the kid understands the pattern. So similarly, the machine learning model understands the pattern when we train the model with enormous amounts of data. That is, the data could be gigabytes or petabytes of data. So once the model is trained, then we will give a completely new image and the model will be able to predict the features of the image, just like how a kid can identify the fruit image. So artificial intelligence AI is nothing but mimicking a human. So can we understand how the human brain is working, and can we train a machine or model with the same information so that a model can do the same thing that a human can do? But how can we train a model? By using mathematics. It's all pattern finding. Therefore, AI means pattern finding. That is either from the structured data, that is your tabular data, or unstructured data. Unstructured data means either text or image or audio or video data, and the intent is to be able to identify the pattern. So the objective of artificial intelligence AI is to understand the patterns from the data, similar to how our brain is working. So that is the objective of AI. So if you notice here, inside artificial intelligence AI we have machine learning, ML, and inside machine learning we have deep learning, DL, and inside deep learning we have generative AI. So generative AI is one of the subject in deep learning. So this is where we will try to spend majority of our time and try to understand what is generative AI and what are these large language models inside this generative AI. So artificial intelligence has information retrieval, IR, machine learning or NLP, natural language processing, CV, computer vision, soft computing, fuzzy logic, etc. So artificial intelligence contains several topics inside it. Now let's see how do we train a model, right? How can we give intelligence to model, machine learning? So how can we give the intelligence to these machines, like logical thinking or mathematical calculations or strategic decision making, etc., right? So that is the whole objective of machine learning. So we need to be able to train a model. So how can we train a model? So first thing is we need to collect the data, right? So first data collection, and the next thing is clean the data. So that is clean all the garbage data, and then feature engineering, that is build the model and then train the model, and then evaluation, that is validate or test the model, and then deploy the model, and then monitor. So this is the complete life cycle of a machine learning model. And majority of the time we spend on data collection, cleaning, or model training, and validation, that is evaluation or deployment. These shouldn't take much time, and iteratively we will do all these tasks until the model predicts accurate results, that is until the model finds the patterns. And we have big companies like Google, Microsoft, Meta, right? So these companies, they automated this entire process. They have collected all the publicly available data present on the internet, be it Wikipedia data or from books or any public data that is available on the internet. They have collected the data, they cleaned the data, they trained the model and provided us with a pre-trained model. For example, we have ChatGPT, Gemini, Olama, Grok, etc. So we have different pre-trained models already available, and all the problems that we can solve using artificial intelligence are divided into three types. So these are different types of machine learning algorithms. We have supervised learning, unsupervised learning, and also semi-supervised learning. So what is supervised learning? This one uses labeled datasets where the input and the corresponding output or target are known. So we already know what is input, what is output. And in case of unsupervised learning, this one uses unlabeled datasets where the input data is provided without any corresponding output or target. And the third one is semi-supervised. So this uses the combination of both labeled and unlabeled data. So what is supervised learning, right? So supervised learning is exact replica of our human brain. That is like how human thinks, right? For example, when we were born, right, we didn't know anything, like we don't know who our mom or dad or anything else, right? But someone has taught you and eventually we learned it. We learn through examples, right? For example, face recognitions. You have seen your mom or dad multiple times. So as a kid, we were able to understand who our mom or dad is and we were able to recognize them. So to identify a person or face recognition, you need a kid to identify the people. For that, you need to provide the input as an image of that person, and the output is nothing but the person name, that is either your mom or dad. And you need to train with multiple images. For example, mom having a long hair or short hair, or mom with specs or without specs, or with mask or without mask, or with different color dresses, right? So the images are not constant, right? The image has different variation, but the kid will eventually understand who is mom or who is dad, right? So deep learning means you need to train with a lot of data, that is either gigabytes or terabytes or petabytes of data, right? So this is called supervised learning. So we are training the model with both input, that is x, and output, that is y. So the model will try to understand the relationship between x and y, that is input and output. So this is called pattern finding, right? Once the model is trained with huge amounts of data, and once the model understands the pattern, that is the relationship between x and y, then given x with any new data, right, the model will be able to predict y. So given x, predict y. This is nothing but supervised learning. And the objective of supervised learning is given x, predict y. And how the model can identify, right? Because we are training the model with huge amounts of data. If this is x, then this is y. This is x, then this is y. So eventually the model will understand the pattern or relationship between x and y, and whenever we give a new x, it will predict y. So which is nothing but a pattern finding between input and output. So training the model means give a lot of examples so the model will understand the pattern between input and output. So this is called pattern finding. So this is the whole story of deep learning. And the next one is generative AI, generative artificial intelligence. So this is a subsection of deep learning, as you can see in the diagram. So generative AI is nothing but a pre-trained model. meaning this pre-trained model has some generic intelligence because the model has been trained with publicly available data. And the objective of generative AI is generating. That is, the model can generate either text or video or images or audio, right? So inside generative AI, we have large language model LLM, right? So we have models that generate either text or models that can generate vision, that is images, or we also have multimodal, means both image and text. So by using these pre-trained large language models, we can perform generic tasks like text to audio conversion or sentiment analysis or conversion from one language to another. All these tasks can be performed by using these pre-trained large language models. And these large language models can be either open source or paid models. If it is a paid model, then we need to make an API call to use the model. Whereas if it is an open source, then you can download the model to your machine and use it. So these models are like plug and play, that is model as a service. So before these pre-trained models were released, to build a model from scratch, it used to take a lot of time. But with the pre-trained model, the task can be done easily. For example, if you want to build a chatbot for a domain specific project, instead of you building from scratch, take this pre-trained available model, give your domain specific data as input, right? Which is nothing but fine tuning or RAG, retrieval augmented generation. We will talk about RAG in detail in the coming lessons because the model is already pre-trained, so the model already has some generic intelligence and you are fine tuning with your domain specific data, so the model will eventually be able to accurately predict the results, right? And when it comes to open source pre-trained models, we have Olama, that is the most famous, and there are like 10 lakh open source models already available in Hugging Face, and we have a separate lesson for Hugging Face. I will talk more about it in the coming lectures. And we also have paid pre-trained models, right? For example, ChatGPT or Claude, Anthropic, etc., right? So you do not have to build the model from scratch. The real challenge in real time is if the model will not be able to predict the accurate results, that is called hallucination, even after training the model with your domain specific data. That is why you need to be able to debug the model or improve the model, right? So that's the real challenge in real time. And the data that we will be training a model can be of three types. We have structured data, semi-structured data, unstructured data. So structured data means it can be your tabular data, that is RDBMS data. We mostly use either machine learning or deep learning when the data is structured data. And for semi-structured data, for example, CSV files, XML or Excel, JSON files, etc. For semi-structured data also, we mostly use either machine learning or deep learning. And for unstructured data, for example, images, audio, videos are nothing but frames, right? So frames are nothing but images or text, etc. And for unstructured data, we mostly use generative AI models, which internally uses deep learning. That is, these are pre-trained models. So machines can identify only when the data has any pattern. If the data is random, the model will not be able to identify the pattern. So this data plays a crucial role when training a model, right? So after feeding so many images to a model, it will be able to eventually identify the pattern, and this entire process can be automated using generative AI. So they have automated this process. They've collected the data, they cleaned the data, they built the model, they trained the model, evaluated and deployed, and these are nothing but large language models. These are pre-trained models. So generative AI uses transformers or GAN, that is generative adversarial network, VAE, variational autoencoder algorithms. We will discuss the architecture behind these large language models in the coming lectures. But with this, I hope you got a decent understanding on the terms like AI, artificial intelligence, ML, machine learning, DL, deep learning, generative AI, or LLM, large language models. So we will deep dive in the coming lectures. Alright, thank you.